First step is factor where possible. On the other page, the ones we did before this, there was nothing to factor. But here, right away, you should say, whoa, x squared plus x, I see common factor x, right? Should be screaming at you. What do you see here? What's that? Yeah, right? Difference of squares. You should be like, oh yeah, it's screaming at me. As soon as I see it, I feel like factoring it. So when you see anything that factored, you have to factor first. So definitely the first step is factor. So let's go ahead and do that. So it'll be 2x, x plus 1, plus x, x minus 1, x plus 1. Okay? You have to factor. Okay? You have to factor. If you don't factor first, then you won't get the lowest common denominator. You're going to get the greatest common denominator, and your questions are going to be a mess. You'll notice, because you're going to have trinomials, and you're going to be like, you want me to multiply this by a No. All your stuff should be binomials. Like, that's my hint to you. We're never going to get you to be multiplying trinomial times a trinomial times a trinomial. Oh, gosh, it's so long. So this right away should be like, there should be a bunch of binomials here, right? Yeah, I don't want you multiplying a bunch of trinomials. So right away you should be like, I think I missed a step. Okay? So now that you see this beautiful factored form, we're going to check. So you can do your restrictions now. Like I said, you can do it now or at the end. It's up to you. Okay, so it's up to you. You can do it now or at the end. I'm not canceling anything, so you can do it later if you want. I want the lowest common. So let's draw this line. Okay, set it up. Okay. Factored denominators, and we want to make these two denominators the same, a matching set. This one has an x plus 1. Right away, you know you have to have that on the bottom here, right? Both of them have to. So if you grab this one, you go, wait, I have to have an x. Yep, so I do have to have an x. So I'm going to grab it here. I'm going to say x. Because this one has an x, this one doesn't. So this one needs to have an x, right? Right away. Look at the monomial. That one doesn't have an x, I got to put the x there. This one has an x plus 1. This one has an x plus 1. Both of them have it. Right? So don't multiply either one. This one has an x minus 1. This one does not. So this one needs the x minus 1. That makes sense? So you're trying to make the two denominators the same. So you go, everything here needs to be there. Then you go to the second one and go, everything here needs to be there. So I always start with the first one and say, everything here needs to be the same. So whatever's missing. So I need an x plus 1 and an x minus 1. Leave it in factored form. That's gorgeous, gorgeous. Leave it. And do I have 1, 2, 3? 1, 2. Yes, they both have a matching set. So once they're matching, then all we need to do is fix the tops. Does that make sense? Right, so matching set of denominators, they both have the same. So on the top here I have 2 times x minus 1 plus, right, so grab the sign in the middle, right, that sign in the middle still goes between them. And then I have an x times an x. You can just go x squared right away if you want. Okay, so x times x is x squared. You can do it in 2 steps if you want. Like that. All right. Then we've got, let's figure this out. So we're going to go 1, 2. Okay, and we're going to go 2x minus 2 plus x squared. The denominator, leave it factored. Factored is gorgeous. Like that. Okay?
Kim?
Yep.
Maybe, well, I don't know, just going off of what you mentioned before, should we bring the x squared to the front?
Definitely. We're not going to leave it like that. What a mess, right? Right away you should be like, ooh, I feel like I have to clean this up. Please clean it up. Try to factor it if you can. Clean it up. You're not going to leave it. That's right away your instinct should be like, that looks so messy. Yes, it does. So we're going to fix that up. x squared, we get plus 2x minus 2, okay? And then on the bottom here, we've got x plus 1. Leave it factored. Isn't that beautiful? So you'll be like, gorgeous, gorgeous factors. And if I have anything I can cancel, I know those are asymptotes, all sorts of beautiful stuff there. Gorgeous there. Here on the top.
Good afternoon, teachers. This is a reminder to submit.
Can't factor it, right? Try to factor it. It is a trinomial. It's x squared x. What two numbers? This is considered the simple factoring with the 1 in front. Two numbers that multiply to -2, add to 2. It's 1, 2. There's nothing. So try, though. Please try. If you can factor it like the other one we did, yep, see? Common factor. If you can, you want to finish it off and make it beautiful, right? So you should right away, oh, that's so messy, right? Fix it up. Try to factor again. If you can't, then you stop. So you have to be able to say, okay, I stopped, I tried as much as I could, comma, okay, and do the restrictions. Remember, you're getting marks for those restrictions, right? Sometimes you do part marks, half marks, 1 mark, stuff like that, but you don't want to forget the restrictions. So here, can we do the restrictions a bit faster yet? Are we getting used to it? Monomial, what's that going to give us? X cannot equal, for the monomial, 0. Does that make sense? Only when it's a monomial. So 0. Can we got this one? -1. And this one? 1. Right? So I'm hoping that you're at the point where you can see some of the simple restrictions without having to work it out. If you still have to work it out, that's fine. Okay, but eventually we hope that you'll be able to do it. The bigger numbers maybe you have to work on. Yeah.
On the test, you want us to do the plus minus?
Oh, I don't mind either way. Yeah, so you can do plus minus. So this you could do plus -1 or like that either. Yeah. So or. Yep. Okay. And it doesn't matter the order. Yep. Okay. All right, next one. Try it again. This one throws people off. Okay? Remember, back to grade 9 again. Here's the pad. Here's my Post-it notes of memory. Okay, if I gave you this in grade 9, I get like this, and then I'll say 1/2, 1/5, like that. What did you have to do?
You have to consider the 3 as like 3/1.
Yeah.
And then you gotta multiply your top and bottom.
There you go. And then, yeah, so it's the over 1. I used to always say, as soon as you see a whole number and you're working with fractions, put it over 1. So what are we going to do? Put it over 1. Right? So the same, everything you need to know was back in grade 9. There you go. So 3/1. Okay? So still do over 1. So we're going to put a little star there. Just remember, when it's just a whole number, any whole expression, you put it over 1. If it doesn't have a denominator, put it over 1. So then you go, okay, what's going to be, can I factor? I can't factor. There's nothing to factor there. Okay, so no factoring. Then we go like this, line up. I set that up. It sets me up so then I kind of remember. So by doing that, I go, okay, now I'm setting up the denominator. So certain things should trigger your memory when you're doing the question. You go, okay, this is the one where I do equals, and now I'm going to look at the denominator only. I have a monomial of 1. I can multiply the other one by 1, but it doesn't do anything, right? So it's not like an x, so I'm just going to leave that. This one does not have the x plus 1, so I like this one to have the binomial. So then here, x plus 1, like that. I want that one to have the binomial. This one doesn't need times 1. So all I need in the denominator now is x plus 1. I don't need the bracket because it's by itself, so I just left it like that. So both of them, right? So one more time. This one's sitting on the x plus 1, and this one is sitting on an x plus 1. So they both are sitting on x plus 1. So that's what I write down. Okay. I still like to write the monomial in front of the binomial when I'm expanding stuff out. It makes me feel like it's easier for some reason, so I do this. It's the same if you put the 3 on the right side and then distribute it that way. Okay, so I can put the 3 front or back. I like to put the monomials there. Grab this sign and put it here. So it's minus. I gave you my first minus here, or second minus. So make sure you grab it and put it here. And this one didn't have anything, so I leave it 2x. Okay. Then you're going to clean up the top as much as we can, factor everything like that. So we're going to expand this one out first, and we're going to go 3x plus 3 minus 2x over x plus 1. Can I simplify that more? Yep, those like terms here and here. 3x minus 2x, so that'll just be x. Okay. Restrictions, please. So comma, x cannot equal minus 1, right? We're good for there. Just the one on the bottom. Okay. Last one. One slight little trick, one extra little something I got to show you. You're like, I got it. Okay, let's try one more. First step. Factor. Factor. That should be screaming at you. Again, they should be like, hey, factor me, right? So the top I can't factor, but the denominators multiplies to positive 1, adds to negative 2, so negative 1. You can write it twice or put the squared. It's up to you. Here, at the end, you clean it up. We'll clean it up at the end. Right now, I don't care. So I'm going to do minus. So the minus is still here. This denominator, x plus 2. And here, x plus 2, x minus 2, right? Difference of squares. Okay, what's my next step? Restrictions, yep, restrictions. So restrictions here. Okay, restrictions would be, I'm just going to do it on this side here. So x cannot equal, from both of those, 1. From these two, yep, positive, negative 2, or you can write them separate. I don't care which, whoops, sorry, like that. Good? Okay, so we got that. I'm just going to circle it so I remember to grab it later. I'm going to grab that in a minute. Okay. Now what do I do? Yeah.
So you can change them. I would change. Okay, the first thing I would do is I'd take the x minus 1 times x minus 1 and make it a squared. So x minus 1 squared.
Yep.
And then I'd add on x
Minus
plus
1
2, x minus 2.
onto this guy? Yep.
Yeah.
Okay. And then this one here, you have a plus 2 and a minus 2, and I take 2 of these and put them here. That is correct. However, also a little something we can do before that. So it's right, but then you're going...
You can factor out the x minus 1 on the top. And
not factor, but what is it called?
reduce.
We can reduce it. Don't forget section 2.4. We started with one set of these guys, and that's all we did. And as soon as we did this, what could we do? If they're the same on the top and the bottom, poke out that hole. So if you do it the other way and you don't look for the holes first, top and bottom, then you're going to end up with 4 of these guys, and you're going to be like, oh my gosh, because then you actually want me to expand 3 and 3 and bring them up. Probably not. Yeah, you're going to be like, wow, probably not. There's a couple homework questions that were pretty big, but like, not all of them should be that big. So you go, wait, 2 of these and 2 of the, that's a lot. That's a lot of expanding, right? So look at it first. Am I allowed to cancel here and here? Denominator here and here. Why not? What if this was a 1? It's not minus. I can't cancel across a minus. The only reason I could cancel numerator and denominator here was when it was times. Remember that? That was from back here. So when I could make the line, I did this. Because it was times, I made the line one big line, and now I can cancel a numerator and denominator. I am not allowed to cancel with fractions. I mean with the plus minus. So I'm never allowed to cancel diagonally if a plus or minus is stopping me. The only time I could cancel was when I could make the line fully long, and then I can cancel. But that's not doing any harm. This is back to 2.4 where we were just canceling numerator with denominator. So we are allowed to cancel any numerator and denominator. Do you know what that's like? Let's go back to our grade 9. What if I gave you 4 over 8 plus 20 over 30? Would you go ahead and try to make the lowest common denominator? What would you do first? 4 over 8 is 1/2. Can't you just make that 1/2 and make it nicer? And what would you do with the 20 and 30? Yeah, so 2 over 3, right? So you would take off the zeros. I wouldn't just, like that would be so much bigger, 240 as your denominator versus 6. So that's why you're allowed to cancel up and down. Am I allowed to cancel this way? No, you'd be like 4. Why would you do that? That doesn't make sense. So you're only allowed to cancel because you're reducing the fraction first. So that's what we're doing here. We're reducing the fraction before we do lowest common. That's why we're allowed to reduce here. Only top and bottom, not diagonally. That makes no sense because that's plus or minus. Does that know the difference? Is that okay? So cancel, which means reduce your fraction first before you do lowest common. If you don't do that, you'll never be able to finish the question. It'll be so long. And at the end, I'll look at you and go, now can you reduce? So look, if I didn't reduce, what would the lowest common denominator be? 240, which is way bigger than, it should be 6. And so you have to go from 240 and reduce it down. Same thing here, right? If you don't reduce first, your denominator is going to be so big you won't be able to finish the question. Okay, so please, please look. If you can reduce your fraction, right, your rational expression first, and I can. Okay, so before I go into the next step, I'm going to rewrite this, and I'm going to go, so now this is just 1 over x minus 1 minus, and here, can I reduce that fraction too? So much better, look at that. And so now I'm just adding 1 like that. And that's so much cleaner. And now lowest common won't have 4 binomials. And you're not going to be like, are you crazy? You want me to expand that thing? Okay, so then now my lowest common is, now I'll do lowest common. This one, there's an x minus 1. This one's x minus 2. They're totally different binomials. So this one needs an x minus 2. This one needs an x minus 2. This one needs x minus 1. Right? Does that make sense? So we're back to that beginning question. Does that make more sense now? So the first question we had was 2 different denominators. And I said just multiply this one by this and that one by that because we want them both to be the same. Okay, so we're back to that other example. Back over here, I'm just going to flip over, so look up. We're back to here. Right, does that make more sense? So here you're like, do I always do that? Well, it depends. We're trying to match the bottoms. So look, x minus 1, x plus 2, I gave you the same thing, almost. Right, so this one, we want them to match and match. So this would be 1 times x minus 2 minus 1 times x minus 1. 1 doesn't change anything, negative 1 does. So on the top here, x minus 2 minus x, that becomes negative times negative, positive 1. Leave the bottom beautifully factored. Can I simplify one more time? Yeah, it's the never-ending question. Right, these are always long. So I get negative 2 plus 1. X minus x disappears. So I get negative 1 over comma, restrictions please, from here. X cannot equal 1 or positive or negative 2. Okay, so that was a tricky one because it's bringing back section 2.4, right? Reducing our first fractions first, so do look for that. Any other questions or clarification? Yes, no? Okay?
So that's one question.
Yeah.
Do you need to, for what I didn't even write the -1 on that. Yeah, there.
Yep.
I just put a minus.
Yes,
instead.
put the minus in. The 1 is just, yeah, just as a placeholder, yeah.
Okay.
Yep. So you don't have to show the -1, just put the negative in, beautiful. You don't have to show the 1 here either, just showing you where I got the numbers from.
Okay.
Okay? Good?